Hey guys, the objective of this video is just to look at formula we're going to be using in the next couple of videos. I'm not going to be doing any examples, I'm rather just introducing the formula we're going to be using and the methods of using them. So we're going to be looking at formulas for area, first moment of area, centroid, second moment of area, and then we're going to be looking at methods of solving these problems using slices and squares. So what we're going to have is some type of shape in reference to reference axes x and y, and then x dash and y dash is the centroidal axis. So these axes act at the centroid of the shape. So to find the area, you would just solve the integral of a over dA. It's pretty simple. The first moment of area, bx, is integral of a y dA, by is integral of a x dA, bx dash and by dash is the first moment of area in reference to the centroidal axes, and these are in reference to the reference axes. So because you're at the centroid, the first moment of area, bx and by dash, is just 0. The centroid, to find the centroid in terms of your reference axes, so we want to know, say, the yc and xc, how far up our centroid is and how far across our centroid is. You would do bx on a for yc, and xc, which is the distance x for the centroid, would be by on a. The second moment of area, ix, is equal to the integral of a over dA y squared. Iy is the integral of a over dA x squared. Ix dash, so the second moment of area in reference to our centroidal axes, will be the integral of a dA y dash squared. Iy dash is integral of a over a dA x dash squared. Now, the method of solving these problems, you can solve them either by taking slices. So we'll take a slice there, for example, dy thick, or a slice there, dx thick. Or you can solve them with little squares, so infinitesimally small squares, dx by dy. Now, the method you want to choose is very important. So when you get a problem, you need to determine which method, either through slices or squares, you're going to be using, because it makes things a lot easier when you know what you're doing. If you've got a simple shape, like a square or a rectangle, using slices or squares as a method, both will work out fine. They're very simple. When you get to triangles, though, which is a bit more complicated, you want to choose your method very carefully. And this is how you know how to do it. When you have a shape like this, a triangle like this, which is enclosed by simple lines, so this y equals 0, x equals 0, and this line would be some type of function. So it'd say like be y equals, I don't know, minus 2x plus 4. I don't know what it's going to be. Let's just say it's that. So when you have that case, you can see you have a y-intercept. Whenever you have a y-intercept, you definitely want to be doing slices. It's not going to make sense now. It's not going to make sense why now. But when we come to the example, you'll see why slices makes sense when you have a y-intercept for one of the lines enclosing your shape. When you have a shape like this, where say this function might be y equals 2x, and this one might be y equals minus 2x, you can see you don't have any y-intercepts. Now, if you don't have any y-intercepts, it's a lot easier doing it by taking squares. So just to summarize that, how to know when to do which method for for triangles. Whenever you have a triangle enclosed by a line which has a y-intercept, do slices. It's much easier. Whenever you have a triangle enclosed by lines which do not have y-intercepts, do squares. It's much easier. So we're going to be doing examples of both of them so I can show you why. And yeah, guys, we'll see you in the next video. Hope that helps.
Cut study time with concise video summaries by top students. Visit spoonfeedme.com to view more free videos in this course and hundreds of others.